Bismillahirrahmanirrahim. Unit 15 Electromagnetism Conceptual Questions from 5 to 10. This is Physics 10 National Book Foundation. Question 5. A bar magnet is moving toward the ring. What is the direction of induced current in the ring when magnet is moving toward the ring? Now, here is a ring shown. This is a bar magnet, north pole toward the loop, the ring, and it is moving forward in this direction. When the magnetic field through a closed loop is changing, this is a closed loop, bar magnet is moving forward, the magnetic field within the loop is changing. It induces a current in the loop. The direction of the induced current is such that it will produce a magnetic field that will oppose the magnetic field that induced the current. That means this will produce a magnetic field. The current in the loop will produce a magnetic field that will have a north in this direction so that it opposes the forward motion. Now, the direction of the current in the loop as well as the north pole of the induced magnetic field is found using the right hand curl rule. If you curl the right hand fingers along the flow of the current in the loop, then direction of the thumb will show the north of the magnetic field due to this current. So when north pole is moving toward the loop, the current induced in the loop will produce a magnetic field which will have north pole facing the bar magnet's north pole to oppose the motion of the bar magnet toward the loop. When the induced bar north pole will be in this direction, it will push this bar magnet away. That means it will oppose the forward motion. Now, using the right hand curl rule, this is the right hand curl rule, and the curl of the finger shows the direction of the current. Now, using the right hand curl rule, the direction of the current in the loop is counterclockwise. That is, looking from this side, the direction of the current in the loop is counterclockwise from the bar magnet. This current is downward at the far end. At the far end, it is going downward, and it is upward at the near end. Again, question 5. The bar magnet is moving away from the ring. Now, the same ring, now the bar magnet is moving away. Now, what is the direction of the induced current now? The magnet is moving away from the ring. Again, using the same right hand curl rule, when the bar magnet is moving away as shown, the current in the loop will produce a magnetic field to attract the bar magnet. That means now it has a south pole moving away. So this current in the loop will have a north facing this south so that it can attract, it can prevent going away because it has to oppose this motion. The current in the loop will produce a magnetic field to attract the bar magnet, the thumb to point the bar magnet to attract the south pole of the bar. The right hand curl that points the thumb toward the bar magnet. This is the right hand curl. Now the direction of the current is changed. This points the north thumb in this direction, that means north of the induced magnetic field. And the clockwise while looking at from the same direction. And now this direction is clockwise. The current in the upward, current is upward in the far end and it is downward on the near end of the loop. Question 6. Why output of a transformer is 0 if DC voltage is applied on its primary coil? Transformer works on the principle of mutual induction. Changing current, that means alternating current, in the primary coil causes a changing magnetic field which in turn induces an EMF in the other coil, that is the secondary coil. In DC voltage, the current produced is steady and does not change. No change in the current, no change in the magnetic field, hence no EMF at the secondary coil. That is the reason that output of a transformer is zero once a DC voltage is applied. Note that when DC voltage is switched on or off in the primary coil, it momentarily causes an EMF or current in the secondary, which again returns to zero. This momentarily EMF registers the change in the state of the primary coil. When the switch is turned on or the off for the DC voltage in the primary, since the state of the current or the magnetic field changes, a magnetic field suddenly emerges, or when it is switched off, it finishes. That is, this change is registered at the secondary and a momentarily voltage or the current is shown. Question 7. Why are coils of transformer wound on an iron core? Iron is a material that supports magnetism. Iron core helps to channelize the lines of magnetic field generated at the primary coil. These channelized lines of magnetic field are then passed through the secondary coil to get the maximum of the mutual induction at the secondary output. Question 8. Why step-up transmission is used for long distance transmission? When electric power is transmitted, there is always some loss of power due to the resistance of the current carrying wires. The power loss in the transmitting lines is calculated as P is equal to, this power is equal to I square R. Now let us understand the situation with the help of an example. Assume in a certain area, the electric company requires to supply 2200 watts of power at the usual voltage of 220 volts. Now for the given power is used at 220 volt, the current to be supplied can be calculated as P is equal to VI or I is equal to P over V. Now substitute the values of the to calculate the current. Since power is 2200 watts, voltage is 220, this gives us 10 ampere of current. That 10 amperes of current will be transmitted at 220 volts. If the required current of 10 ampere is transmitted at 220 volt through a cable having a resistance of say 50 ohms, I've taken a very small resistance for the current carrying cables. The power dissipation can be calculated as P is equal to I square R. Now if P is taken as 10 ampere and the resistance is 50 ohms, this returns 5000 watts. Now just imagine 5000 watt is the loss of power during transmission for an area where you have to provide only 2200 watts. This is exorbitant. This is too much of loss. Unrealistic. This is not in the actual case as well. Now, if the same power of 2200 watt is transmitted at a very high voltage of, let's say, 500,000 volt, the current for the same power will be I is equal to P over V or I is equal to 2200 divided by 500,000. This gives us a current of 0.0044 ampere. Now calculate the transmission loss using P is equal to I square R or P is equal to power is equal to 0.0044 square multiplied by 50 ohms. This gives us 0.000968 watts. This is the power loss. This is very, very small, almost negligible power loss. So the answer to this question is, in order to transmit electric power over long distance, the voltage is stepped up to maybe about 500,000 volt, which reduces the current to a very small value. This is done to prevent the line losses during the transmission of electric energy. This is the brief answer to this question. Rest was all explanation for you to understand why it is done. Question number 9. When you are pushing a bar magnet towards coil of a single turn, you feel an opposing force on your hand. And if this magnet is pushed towards coil of many turns, now you will feel greater opposing force. Why? When bar magnet is pushed towards a coil of single turn or multiple turns, a current will be induced in each turn of the coil. The direction of this current is such that it produces a magnetic field that opposes the motion of the bar magnet. Now, in case of a single turn, the magnetic field thus produced will be relatively a weaker field, giving a weaker opposing force as compared to the field produced by many turns, which will sum up to that force, opposing force will sum up to result in a greater opposing force. Hence, you will feel a greater opposing force on your hand. The push force on your hand is felt greater. Question 10. In what way split rings commutators differ from the slip rings in AC motor in working? Now, here is the difference of split rings and slip rings. Split rings are used in DC motor, slip rings are used in AC motor. Split rings are two half circular rings. This is the shape of or the construction of these split rings. Whereas slip rings looks like a continuous or complete circular ring form. The purpose of the split ring is to reverse the polarity of the current to ensure continuous torque, whereas the purpose of slip ring is to provide continuous and steady supply of the current. Now that is all the questions from the conceptual question point of view. So see you later. Thank you very much.